Have you ever squeezed an orange skin? When I was a kid, we used to spray each other. And to this day, opening a French orange reminds me of these orange peel fights. A bit silly and childish, but hey, everybody does stupid things when they're 7 or 8. I could still smell orange on my hands and clothes hours after, which was really nice. But how come these tiny droplets, sprayed from just the surface of not just oranges, but also lemons, grapefruits, and any citruses, can have such a powerful scent? Citrus peels have been used for fragrance extraction for millennia. The food industry, perfume industry, cleaning product industry use combinations of these complex chemicals called essential oils in their products to produce their identities. So let's follow the scent and see where it takes us. This is Think 4. Essential oils are concentrated extracts from plants. They are not just from citrus peels, but they can be extracted from almost any part of a large variety of plants, like the flowers of lavender or the bark of cinnamon tree. They have a large range of uses. Essential oils from lavender, rosemary, peppermint, cinnamon, ginger, or oregano can be used in cooking. Essential oils can obviously be used in perfumes. Their composition is a well-guarded secret. For example, channel number 5 contains bergamot, lemon, jasmine, rose, ylang-ylang, cedarwood, vanilla, and more, but I would be incapable of giving you the exact quantities. Essential oils have also been used for centuries for their medicinal properties. Tea tree oil is used as an antiseptic. They are usually like edible oils, insoluble in water. They are also volatile, meaning they easily evaporate at room temperature, making them easy to diffuse and perfume a room. Essential oils mostly contain a family of compounds known as terpenes. This family of chemicals are based on isoprene units joined together. Terpenes are then going to be a multiple of the C5H8 unit, repeating n times. Terpenes with all number of isoprene units are found in nature. For example, they can be as small as 2 isoprene units, like limonene found in citrus, carvone found in spearmint, or myrcene, a terpene responsible for woody smell. But they can also be as large as 6 isoprene units, joined together to form terpene like squalene, found in shark oil. Terpenes can be altered over time to form new compounds which will have different properties. This is why most essential oils will have a use-by date on their bottle. The culprit? Oxygen. Indeed, terpenes can undergo an oxidation reaction. Some of these new oxidized compounds will be desirable to form new fragrances and properties. The peppermint flavor, for example, comes from a terpene called menthol and its oxidation counterpart, menthone. Both compounds will contribute to the peppermint aroma we are so familiar with. But in other cases, it can be more problematic or even harmful. Alpha-terpene present in tea tree oil will react with oxygen present in the air to form ascaridol and p-cymene. And these oxidation products have been linked with allergic reaction to tea tree oil. To counter these unwanted reactions, essential oils are usually stored in sealed brown bottles to avoid contact with oxygen and reduce exposure to light, which can be a trigger. So, when I was squeezing those orange peels all those years ago, that is what I was playing with. Natural chemicals produced by plants that offer us these lush and diverse fragrances. Next time you bite into a nice and juicy orange, slice a lemon while cooking, pick up a couple of leaves of mint from the garden, or rub a couple of lavender flowers between your fingers, take a second to appreciate some of these natural chemicals and smell the fragrances that essential oils have to offer. Understanding this stuff might bring you the sweet smell of success in higher chemistry. This was Think 4. Thanks for watching.